Okay, so this is Minitest 25, and we're looking at question 2. So we have got three forces acting on an object, and the object is in equilibrium. So if it's in equilibrium, the resultant force must be 0. So I can form an equation, basically, that says that plus that plus that must equal 0. I'm going to do that writing them as column vectors. You don't have to, I just find it much easier to do the arithmetic. So the first vector is 2ai plus 2bj newtons. And the second one is minus 5b plus 3a and minus 11 minus 7. And both the horizontal and the vertical resultant forces must equal 0. So looking just at the horizontal components, the top row, 2a minus 5b minus 11 is 0. So that's one equation with two unknowns, a and b. So I'm not going to be able to solve it from that alone. Then I've also, so before I simplify that, I'll write out my other equation. So looking at the y vectors, I've got 2b plus 3a minus 7 equals 0. So it's just a case of solving the simultaneous equations. So I think I would probably do that using elimination. It's entirely up to you. So I'll call the top one 1 and the second one 2. So I'm going to make them both equal 6a. So if I multiply my top equation through by 3, I'm going to get 6a minus 15b, and I'm going to add the 11 times 3, so 33 over to the right hand side. And then if I times my second equation by 2, and I'll switch the order as well, so I'm going to get 4b, I'm going to get 6a, and I'm going to get that to equal 14. So if I subtract those, 6a minus 6a is gone, minus 15b minus 4b is minus 19b, and that's going to equal 19. That's nice and easy. So b is minus 1, and then I'll just go back to this equation. So if b is minus 1, 2a plus 5 equals 11. So 2a is 6. So a is 3. And then let's just go back. So what did it actually ask for? So yeah, just ask the vectors, sorry, just ask the values of a and b. So I don't need to actually say what these two vectors would be. So that's great. I've got my two answers.